Okay, so let me present my screen first. Okay, so this is basically a kind of revision class. So we can go through whatsoever we have done in this course. So we will just go through some of the topics which I thought may be important to you. And if you have any question at any point, you can ask, or if you have any doubt. But regarding the exam paper, I think you have already got that what is the kind of this examination. I think there are some MCQs and then some essay types, so maybe some place where you may need to basically write also. So that I don't know because like Prashant sir will handle mostly or maybe the sir directly, the instructor. So I do not have idea regarding the exam pattern or something like that, but I'll just try to cover whatsoever we have learned till now. Okay, so okay, so we are basically moving to. I have taken some topic or questions what I thought may be good. Okay, so now there are some questions. Uh, Basically, what you need to do is that firstly you need to. Okay. So, firstly, you need to go through whatsoever we have done in 12 weeks till now. Uh, just this. Okay, so firstly, you need to go through that. Make sure you, at least if you do not have so much time to do the coding, make sure you run the codes at least which I have given. And then you can understand at least that what is happening inside the code. Okay. Okay. Is the class regarding to the exam? No, I do not have. Basically, I do not have idea which kind of exam type will come. So what I'm trying to do is that basically the places where you can have like you may not remember exactly or the places basically which at which point you may think that okay either it is this or this, so a bit confusing, or there are some things like loops which are basically very important part. Okay. So I think you can have good number of questions from that. uh, and then order list, because see till now you know how you can define a data vector. You need to write C and then inside you need to put the values. You know how to define a list. You need to write list and then you can put like whatsoever data vector you can give. So let's say you have two data vector, you have a list, you can merge it, you know all these things. But then there are some things, let's say you have matrix, you have written a matrix, then uh, if for r bind, like what is the necessary condition to have that we can apply r bind or c bind. So these are some things which you can recall in this class, so that will be much better. Okay. So these are some things, but what we have done till now is basically this was the very first one. uh, and then we have just started what is the data vector, what is the numeric, finite, infinite, and then we have started with the basic mathematical operations. So basic mathematical operations, you know, the with the data vector what are the operations we can do. Then the power operation can be done by this, then the integer. Now you need to remember that how exactly what is the integer and modulo division. So if let's say you have a question where, I mean, if you see the slides, you think that you know all everything basically. That happens to me also. But when you are doing the coding by yourself, then a lot of time it happens that you may not recall what is exactly the integer one and what is for the modulo one. So that is, you can remember by like something with yourself. So you may think that okay, we have two percentage sign, if there is a bar in between, so in general we do the division. So if there is division, then we have the quotient because we have the main value. So that way you can at least try to remember all these things. Okay, and then there is built-in functions. So we have seen that why we need to give the data vector as it is. So to find like if I try to find min, I can just find the min of 2 5 directly, right? So it is 2. I can find the maximum of 2 5, it is 5, we know that. But as soon as you go to mean and you write 2 5, it is not going to work. Whatsoever is small value you will write, it will give you that. So with mean it is not the case. So you need to remember that where whenever you are giving inside a function mean, minimum, maximum, then there will be skewness, kurtosis, etc. Whatsoever you will give, you need to write inside part as a data vector. So if until unless you are not giving it as a data vector, you will not find I mean, sometimes let's say mean, minimum and maximum you have the correct values, but for the mean you have wrong values. So at the end, you should remember that use the data vector. So these are some basic points which, let's say you have the mean and then it may happen that you have written something else. Then the matrices. So we have already seen how we can define the matrices. At any point, if you have any doubt regarding any of this part, you need to stop me, because like in 2 hour it will be very tough to go through each and every part and explain it. Okay, so for most of the part, I'm gonna say that okay, we know how we can define a matrix and we know how can we do a basic summation and all. But if you do not remember how we can do that, if you do not remember what is the dimension we should take for summation or multiplication or something like that, you need to stop me. Okay, or you can just send a message that okay, I need to recall this also. Okay, so these are the questions we have done. So you can go through all these slides, you can try to solve these questions by yourself. Okay, so next, what we have seen is that in the basic metrics, when we define, we can change its row names, its column names. So I have written call names because we do it by row names and call names. So I have written by directly functions. Okay, now the next one is diagonal matrix. So diagonal matrix is basically when you have values only at diagonal, not at any other place. So in that way, we do not need to write 0 0 0 0 0. We can just define by diag. So diag, and then inside whatsoever value you will put. So mm, let's say I'm putting, right, and x is equal to 5, or x you do not even write, need to write this, and row is 3 and col is 4. See, so it will come like this because diagonal is ending at this point. So at 4 there is nothing. If you will write like this, then you will find there is a square matrix, a square diagonal matrix with this x whatsoever you will give. If I will give uh, 10, then you can have 10 at these places. Then there is transpose. So basically all this is the matrix, then if it is like this, it will just shift to like this. So whatsoever was in row, it will basically change to column. So if you have right now a matrix with 2 row 5 columns, then your matrix, transpose matrix, will be 5 row 2 columns. So that is basically just you need to write this and then write like this. So that will be the transpose one. And the transpose one you can do by just T, and inside you need to put that matrix. Then we have the basic operations. So before moving to operations between two matrix, we will see that how we can have the operations inside a matrix. So inside a matrix, basically we can find the row or column operations. So we can find row sum, row mean, and then there are other which like which you can do based on like row mean and row column are basically automatically defined. So if I will write, you can see that uh, row names you can change, row means you have already, row sum you have already. Okay, row sum, yeah, row sums. Okay, these you have. If you want to find let's say you want to find some skewness or some square root, or you want to perform some other operation, then you need to define it in a way that it will take the row values. Okay, then we had that how we can access a particular row, a particular column, or a submatrix. So let's say I am writing this as x. So if I will write x1, so this is x1. If I will write x1 to 2, then it is 1 to 2. So let me just print firstly x, remove all this so it will be nice and clear. Okay, so now what I have written that I want x1 to 2. So first, always first one is regarding the row, second one is regarding the column. So 1 to second row. Okay, so 1 to second row, uh, I have this row. Now in this row, I do not want it full. I have given in the second one what I want. I want 2 to 3 column. So 2 to 3 column is 0, 0, 10, 0. So my x1, 2 is 0, 0, 10, 0. So that is a submatrix. Okay. And if you want to access any of it, this, then you can write basically x1, x2, or whatever is the index. The next is the mathematical operation with the scalar. So mathematical operation with the scalar is basically adding, subtracting, multiplying, and basically dividing something. So basically with a scalar. So I can basically do x plus 2. I can divide x by 2. I can multiply, and uh, I can subtract 2. Okay, so these are some basic operations, basic mathematical operations with the scalar. Now till now we have not given any condition on the matrix, right? You can have matrix of any form, basically 3 by 4, 4 by 3, there are no conditions. But when you have mathematical operations with a matrix, so then there are restrictions. Okay, so these are the examples here. Maybe I have written. Mm, okay, so as you can see, so with the scalar there is no dimension rule. You can have matrix of any dimension. When you have matrix operation with the matrix, so let's say you have two matrix m1, m2, then if you want to do summation or subtraction, okay, for both the condition is same. What is the condition? The dimension of matrix 1 needs to be same as dimension of matrix 2. So if it has two rows, it has to have two rows, and if it has three columns, then it will have three columns. Then only we can perform these two operations. But for multiplication, it will not work. For multiplication, if you have a square matrix, then you do not need to take care of the dimension because it is 3 by 3, 4 by 4. So obviously it will all be same row, column, etc. But if you have different dimension, so for that, for summation subtraction, the rule are r1 multiplied by c1, so both needs to be same. But for the multiplication, let's say the dimension for matrix 1 is r1 times c1. Okay, so r1 times c1, let's say it is 3 by 5. Let me change the color. It is similar. Okay. Okay, so it is 3 by 5, let's say, for m1. And for m2 it is r2c2. So what is given? To multiply m1 by m2, yes, there is one more thing. uh, the basic thing, for summation subtraction, 2 plus 5 is same as 5 plus 2. So for matrix also, m1 plus m2 is equal to m2 plus m1. For subtraction, 2 minus 5 will is not equal to 5 minus 2, but it is the negative. So 2 minus 5 is basically minus of 5 minus 2, right? So for subtraction that happens. So m1 minus m2 is basically minus m2 minus m1. Okay, that works. But for uh, multiplication, this will be completely different. m1 into m2 will not be equal to m2 into m1. It can happen that these were equal for very rare case, that will be exception or that will be the specific case, but in general it does not happen. So uh, if you want to have if you want to multiply the matrix m1 with m2, then what you need to do is that, uh, for m1 by m2, you need to have c1 equal to c2. Why? So here is the explanation. Okay, so I'm just removing so we can write. Will R be provided during the exam? I don't know, but I think you should write this in discussion form. But uh, I don't know, maybe or maybe not, because if R will be provided, you already have all these functions defined with yourself. So you can basically directly go and then find whatsoever should be the result. So, but still, I'm not sure. Okay. Okay. So what we were saying, for m1, m2, let's say I want to multiply m1, m2, and it has r1 times c1 and r2 times c2, then you need to have this c1 and r2 same. So which I have written here, c1 and r2 needs to be same, and then this multiplied matrix will be of r1 times c2. Okay. So similarly, if you want to do for m2, multiply by m1, then c2 will be equal to r1. Okay. So this was regarding the dimension. And I hope you know how to do the matrix multiplication. So summation we do element wise, subtraction also we do element wise. But this matrix multiplication we do like this. So I have given one example, so that is, you can go through basically that, if you have one this and one this, then it is not this, it is, this one is wrong and this one is the correct form. Okay. uh, Okay. The next thing is that after dealing with the mathematical operation, so these are basically mathematical operation. In the last one, so we have seen summation, subtraction, and multiplication. The division is not. We do not divide the matrix. What we do is that if A divided by B. So A divided by matrix B is basically A B inverse. Okay. So you can write like this: A multiply by 1 upon B. Okay. And then 1 upon B is basically B inverse. So you need to multiply A by B inverse. So that will be your A by B. Okay. Okay, so inverse, how do we do inverse? We do inverse by using this solve function. So that you need to remember that there is nothing like an inverse function here. So you are not going to write inverse of a matrix. You need to write solve this matrix, and then it will give you the correct correct answer if you will write solve instead of this. Okay. Then there is concatenation, we will see, and then there is eigenvalues. Okay, so concatenation is basically uh, so let's say I have m1, I have m2, and I want to stack it. Okay, so I want to stack, let's say, m1 side by side of m2, and or I want to stack, let's say, m2 below m1. So then there is one is column wise and one is row wise. So you tell me, if I have m1 and I want to stack m2, then what should be the condition? Either what should be the condition means it's row needs to be same or column needs to be same. Okay, firstly tell me, when I'm doing m1 and side by side of m2, whether it will be c bind or r bind. Like I want m1 m2, there is one way, and I want m1 and then m2 whole matrix. Then in which of these I will write r bind, and like for you can write in message that one can be r bind or c bind and two can be r bind or c bind. So what will be your answer? For first case you have r bind, and for the other it is c bind. Okay. Okay, now let me just write one diagonal matrix. I'm gonna write. Okay, so n row 3 and column 3 y, and I'm gonna do r bind xy. Okay, so first one is c bind and second one is r bind. Okay, now how you can remember this? How you can remember this? Uh, for the C bind, okay, when you have m1 and m2 like this. So let me just do this also so you can see x, y. Okay. For C bind, C is column, right? So C bind means, let me write it here. Uh, C bind is concatenation of columns. Okay, of columns, or you can write column wise. Okay, so from C you need to remember that we are writing it column wise. Okay, column wise. When I'm writing r bind, so you need to remember that concatenation of row or row wise. Okay. So firstly what we have known is that uh, here, since it is coming m1, and then the columns, all the columns are coming like this, and then it is coming in this way. So for this you will have uh, c bind. For this you will have r bind. Okay. The next thing which you need to remember, I mean, I don't know if you will have that much time in exam or not. Okay, so when you have m1, m2, m1, m2 like this, so what do you think needs to be same in c bind dimension? So what do you think, the dimension of rows needs to be same or dimension of column needs to be same for c bind? Okay, yes. So for C bind there is row and for R bind there are columns. Now why exactly is that? So okay, so if I have a matrix, let's say, okay, so let's say 1, 2, 3, 4, 5, 6. Okay, and I have a matrix 1, 2, 3, 4. So now, if I just want to write 1, 2, 3, 4, 5, 6, and uh, uh, after that I want to write 1, 2, 3, 4, then I can write it like this. So, number of rows needs to be same. But if I have a matrix like 1, 2, 3, 4, 5, 6, then I cannot write it like this. Why? Because now there is like m1 m2, I can write 1 2 3, then 1 2 4 5 6, then 3 4, but for the last row there is nothing to write, so we cannot write like this. Okay, so what do we have? We have the matrix this kind. Okay, so this will work here in c bind, sorry. So here rows needs to be same, because you can increase as many columns as you want. Okay, the next is r bind. So if we will take this example to r bind, what will happen? So 1 2 3 4 5 6, so it came like this: 1 2 3 4 5 6, and then we have 1 2 3 4, and this is blank. So in matrix this does not happen, so this will not work here. Okay, so that one worked in the above. For this, what will happen if you have 1 2 3 4, and if you have 1 2 3 4 5 6, then you can do it. So we can write 1 2 3 4, and then after write that we can write 1 2 3 4 5 6, then there is no issue. So what is the condition here? Here you need to have same number of columns so that the columns can stacked like this. Okay, so here we will have column is to be same, number of columns basically, not elements obviously. Okay, okay, so so the next thing is that inverse, which is very direct thing. You need to write solve, and then you need to put the matrix inside of it. So if I will do solve y, so you can see it is very the direct matrix, so it has just solved. But otherwise, when you have tough matrix, you cannot work like that. So you need to write solve and then put x or y whatsoever you have saved matrix. And then the last one is eigenvalues, eigen or eigen, whatsoever you prefer. So eigenvalues are basically the values which we get by using this a minus lambda I. So first thing is that this works only for the square matrix, because then again when I'm doing lambda I, so I is identity matrix, lambda can be anything. So if you have identity matrix, all the identity matrix are what? All the identity matrix are square matrix. So you will have identity matrix. This is the identity matrix, okay, of dimension 3. So if you have identity matrix of dimension 4, that means a 4 by 4 matrix, and all the diagonals are filled with 1 and other values are 0. So to do that, what do? We do this, okay. So we have our main matrix, we do minus. So that's why, because for summation subtraction we need to have same kind of dimension, and since I is always always a square matrix, lambda is a scalar value, okay. So I mean lambda can have lambda 1, lambda 2, lambda 3, that will be a vector, but it is basically one of the scalar, I mean it will multiply like this, okay. Then so the next is a minus lambda I, and we need to find the lambda from here. So a is our matrix minus, so a, and then all the diagonal elements will be subtracted by minus lambda. So let's say you have 1 2 3 4 5 6 7 8 9. So your a minus lambda will be a minus lambda, 5 minus lambda, 9 minus lambda. You take its determinant, and after taking the determinant, so basically if you know the determinant, you can basically solve it. You can write it, you will have an equation with yourself, and with that you can find the lambda. So those, I mean, by rather than doing this much of procedure, we just do the coding, okay. So we can just write like this the eigenvalues of this. So let me see if we can find this eigenvalues of y. So eigenvalues of y are 5, because that is basically a very uh, again it is the diagonal matrix, it does not happen. And then you have the corresponding eigenvectors. So that is one thing, okay. uh, then the next we have gone through missing data. So we have seen how we can get this missing data. We can firstly, na is missing data, null is not missing data, okay. Na is basically what do we say, that the data, let's say you have data at 10 places, and one of its place someday the data is missing. So I mean it can be a fault of machine or whatsoever, but you have a missing data. But null is basically that have not existed at all. Then we have complete cases. So basically, the place where data is not missing. So if you have X, let's say 12, 13, NA, then 12 and 13 are complete cases. Okay. The next is that find the mean. So it is, I have written just find the mean, but It is not just mean. Whatsoever operations you want to perform, the first thing what we do is that we say it like data cleaning or something like that. So you can either write x na dot rm is equal to true, or na dot omit x. So if you have very small data vector, then you can use just first one. But if you have large data vector, I mean, you can use the first one there also. But if you want to perform, let's say, a lot of operations, not just mean, and you want to do some kind of modeling, then you are not going to write this again and again. Na dot rm is true, na dot rm is true. So what do we do is that we save. Okay, so let me just write. So if I will just write x1, uh, c 13, 15, NA, 18, 19, and then 23. Okay. So if I want to find mean of x1, firstly, it will give you NA if you will write directly. So I need to write NA dot RM. So NA dot RM. RM, we basically do, if you may recall, RM list equal to LS. We use RM we use rm to remove, right? So na dot rm means remove all the na values. So na dot rm is true means remove all the na values. So that is 17.6. Same will happen if I will write na dot omit uh, x1. So you will have same value, but what we can do is that, let's say now I want to find summation. Okay, I think summation can be done. Okay, so now if I want to find summation, I need to write it again that na dot rm is true. Rather than that, what we do is that we write y1 as this, and now once we have saved, we can just perform all the operations on y1. We can do this, we can do this. So, if you are dealing with a large data, you are not going to write this na.rm true or again and again. So, that will be a much better option to save it somewhere. The next one was control structures. Now, this is the main part, okay? This is the main part why I'm saying like this. They, because there are basically the conditions. Okay, uh, the first one is that if, the next one is if else, then we have nested if else, then we have if else yes or no. Okay. Okay, so firstly, what is if? So if inside whatsoever condition we are giving, let's say my x is 12, and I want to say that if x is greater than 10, then do this operation. Then if condition satisfied, it will give you result, otherwise it will not give you any result. So what I can do is that I can basically open so that you can see this along with. Okay, just open uh, this week 5. Okay. Okay, great. So uh, fine. So if you have, let's say, x is 12, so what if condition satisfied, then it will give you answer. If condition not satisfied, it will not give you any answer. Okay, so you can see, since x1 is not less than 4, there is basically no answer. Okay, it will just come to the next line. There is no answer. Again, next is that you may not want this. So what you may want is that if this happened, then do this, otherwise do this. Okay, so then there comes if else. So if the condition satisfied, you will have one result. If the condition not satisfied, then you will have other result. So what we have done here, if the condition satisfied, you need to find its square root, otherwise you need to find the sign of it. So since x is 12 and 12 is not less than 4, so else condition will come. So it will be sine of x1. So sine of, if I will write sine of 12, you can say it is minus 0.05, something like that. The next is if else. So now you can nested, you can perform as many nested operation condition as you want. So you have nested if else, you can have if else, if this not happen then if, then you can have else if. So it is not that you need to have basically two else if or something like that, but the more you will include, the more complex it may get. And the complexity is not a problem. The problem can be whether you are able to understand that code exactly, just that what is going on in that. Okay, fine. uh, so here, let us say I have given it one condition, that if it is divisible by 5, then do this. If it is divisible by 7, then do this. Else do this. So what do you think will work? First condition, second condition, or third condition out of all these? We have given one condition, two condition, and if both of this condition not happen, then obviously the third condition will satisfy. So what do you think will be well satisfied among all these things? See, yeah, correct. So you can see that this will not. So ceiling of square root x1. So square root of 12 is basically 3.46. Ceiling. Remember what is the ceiling? What is the floor? So you can remember this. It is basically the round of whatever float values. You can remember that whatever values, you always have ceiling on top of you, right, and floor below of you. So so floor of x1 will be below of that value, integer what is below of that float value, and ceiling, since it is always on the above, you can remember by this. So ceiling will always be the upper one. Okay, so it is 3. If it is 3.4, 3.8, it will be 4. Even it is 3.1, then also the ceiling will be the upper integer. Okay. In the next one, what do you think will work in this one? Again, you have first condition, second condition. If not satisfied, third condition. What do you think will work in this? Yeah. So you can see that this is 12. So 12 is not divisible by 5, but 12 is divisible by 6. So if I will run this, answer will come out of this, the cos of x1. So which is 0.08. So if I will write cos of 12, you can see it is the same. Okay. Now, uh, okay, so we will see this in a minute. Okay, so this is, we have seen if, else, if, else, if. Okay, so if, else, if. Okay, next is that if, else combined. Okay, you can see here it is if, else, if. Remember all these function how we are writing. Okay, we are not writing if else, we are writing else if. Okay, here up to here, but if you are writing if else, there is just no gap between that. Is yeah, this one is the revision class. Okay, so in if else, what do? We do the test. So we do the condition whatsoever happen. It is basically like if else. Okay, so if condition satisfied, this will work. If condition not satisfied, this will work. But there is a difference which we will see. So you can see first condition. So condition, it is not divisible by 5. Condition not satisfied. It will work like this. Uh, Now I have given here x. Okay. Uh, okay. So if I will do this, okay. So I can perform this if else not just for one value for 12, but we can perform this for x, basically a data vector. So in that data vector, first is divisible by 5, second is not, and everything else is not. So for the first one, it is divisible by 5, it was 15. So 15 times 2, let me just write x here so you can see. So 15 is divisible by 5. So the answer is yes, condition satisfied. So it will be 30. The next is 18. 18 is not divisible by 5. So it will be cos of 18. Similarly, these are the NA values, these, and then 13 and 12 are also not divisible by 5. So it will be zero point 0.9 and zero point 0.8. Then we have again similar thing. Then we can make this if it is divisible by 2, then print it is a even number, otherwise print it is a odd number. So this one is odd number, this one is even number, then NA, then odd number, and then even number, and then NA. Okay. Uh, the next thing which I have not written here, but let me just write to show you. If I'm writing, since you have seen that for if else condition, I can do this condition, right? But for if I will do x less than 4, then do square root of x1. You can see that error in if x less than 4 condition has length greater than 1. What does that mean? We have done this already, so can anyone tell me what does that mean? I have given if, and inside x I have given as a data vector. So what do you think can be the problem here? This is my x, and if I'm applying x less than 4, then do square root of x1. Why do you think this there is an error? Yes. So it no, there it is not error because of NA, because if I will give, let's say, another data vector, let me give uh, C 4 5 6. Okay, this is one data vector, or 4 4 6. Then also it will give NA. The reason is condition has like length greater than 1. You need to remember that in all these three, uh, length needs to be 1, no restriction of length. So you can see that for if else, nested if else, for all this, the length of that data vector should be equal to 1. Now it is basically useless if you can apply each of these things just for one value, right? It is very useless. So if basically I want to do check for, let's say I have a data vector of 1,000 values and I want to check one particular condition and I want to apply else if, nested if, else if, then I can only check one by one. So that is very tough, right? uh, or otherwise, so one option we have, if we have only two conditions, okay, then we can give the date, sorry, if we have basically only one condition, that if satisfied, then okay, do this, otherwise do that. So in that place we can do if else. But if we have 3 to 4 condition in one go, then we have to go through for else if. So for that we use loops, okay. So what do we do is that we make a loop and we say that, okay, uh, let's say for I in 1 to up to, let's say 50 is length, and I'm gonna write my x as xi. So it has taken now x as x1, and it will take now x1 is basically one value. If it will do condition if else etc, and it will save result in some y, okay. And that y we can return as a data vector, as a list, or as a data frame, or whatsoever will be the result, whatsoever we want to perform. So that is why, like, there are a lot of reasons to use the loop one, okay. uh, the next is switch and which. So switch is basically, there is a first value. The first value will tell you that where you should go, okay. So whether you should go to third index, fourth index, whatsoever, after that all the values are your data in switch. So if I have written switch to 3, that does not mean it will come to 3. So third, this value is your condition or whatsoever, that you need to go to that index. So 3 indexes, 1 3 4, the 4 have third index, so it will give you 3. If I will write 2 here, then it will give you 2. So the first one is basically, because I'm writing it as values, it seems to be very tough, okay. So first one is telling you where you need to go. If you will come here, it will look much clear that third is where you need to give, you need to go to third index. So you will start counting your index from here. So you have first index, second index, third index, and fourth index. So third index is 4. Now it is not always that you need to give the index, you can give a particular place also. So when we have very large data set, we can basically switch that, we want to switch to a particular column or to a particular value. So let's say I have saved a lot of name, then also, so it will come to this. But if I have written something which is not inside this, so in name there was name defined, but if I'm writing the percentage, then there is no percentage, there is name, gender, marks, there is no percentage. So it will just give you no answer, it will not give you an error. Okay. Now, which is basically finding the index. At what index this is happening. So, which y1 is equal to 16. Which y1 is this? Okay. So, y1 I have given like this. This is the y1. Okay. Okay. Let me run this again. Okay, so which y1 is 16, 1, 2, 3, 4, 5, 6, 7. So this is the seventh index. So it will give you seventh index, which y1 is divisible by 6. So it is 12 and 18 are divisible by 6. So 12 is at third index and 18 is at ninth index. So which will tell you where it is. Which dot max will tell you what is the maximum, at which place it has the maximum. So x is this. So 2 is not the maximum value. The value at which second, the value at the second index will be with the will be the maximum value. So x, you can write x and then which dot max is 2. So this one is your maximum value. So this is the index of maximum value and this is the maximum value. Similarly, you can have the minimum one. Okay, and then in a matrix, there's a bit different. So if you will write like this, that which uh, let's z1 z2. So if I'm writing like this, 1 2 5 7 12, so you can see all these are indices. Okay, but then in matrix we don't know exactly what 1 2 3 4, we do not exactly go to this. So for that we write array dot index is true. So array dot ind. So now it will tell you first row, first column, second row, first column, first row, second column. And these are basically the places when you have the even number basically. Okay. Then we have these very common exponential, log, logarithmic, like there are a lot of functions. So we have done a square root, there are trigonometric functions, sine, cosine, tan. I mean, there are a lot of built-in functions which we have seen. Okay. Till now, if anyone have any questions, you can ask. Nobody have any questions? Okay, that's great. Okay, so so I'm question 18, week 4 assignment. Okay, let me just find this. It is exactly question 18, week 4. Okay, so this is the question. Yes, okay, fine. So what are the conditions given here? Okay, so basically, let me write this firstly, and I am just gonna write x is equal to 21. Okay, x equal to 21, and I'm gonna write this. Okay, it is true, and I'm gonna write x equal to 45, and I'm gonna write this. Okay, false. So okay, so basically there are a lot of things to check. So let me just copy this here. Okay, Yes. Okay. So, firstly, okay. When we are doing for 45, so 45 is not less than 25, but it is less than 22. So it is correct. Okay, true. Then true, and it is not less than 25. Uh, so it is false basically. And here it is not equal to 27, and then it is um, false. Okay, so what we can do is that we can do term wise. This is true, this is true. Okay, this is false. Okay, the problem is basically I can see it is in double end. Okay, so I have written this actually in my next week's in the four. Okay, so okay, yeah. So that was the problem which I have also given here. That if you have this double and or double or with LHS, or if evaluated RHS of length greater than 1, okay, then it is a error. Okay, that one is for greater than 1. Okay, so this one is true, and this one is false. So false and double and also then it is true. Uh, Here this one is false and this one is true. Let me remove all this and we will do it from the start. Okay, now x is this. We basically check from the last actually. So this condition is false. Uh, this condition is false. This condition is true. This condition is false, but this is true, so it is going to be true. So let me break it more for you. Firstly, this is false. Okay, we are doing with 2. This is also false. This is also false. This is also false. But as soon as we go there, this is true. Okay. Uh, so what is happening? Basically, we know x is not uh, uh, x is not equal to 27, but x is equal to sorry, x is also not greater than 22. So this is false, this is false, there is or operation, this is false. Now this is x is less than 25, which is true. X is less than 25 is true, but this one is false. This is true, but true and false is false, right? False, false, or false and anyone will give you this. So true and false is false. So we have done till now, and till now we have a false condition. Now x is, this one is also false, this one is also false, this one is also false. So false and false is basically false. Okay, but at the end it is true. So true or false is true. So if you do condition wise, it is true. Is it clear for the first one? 21. We always do from the last. Okay, that you need to remember again. Always from the last. Now for the next one. Now x is 45. For 45, not equal to 27, false. It is greater than 22, right? So greater than 22, so true or false. True or false, any condition satisfied, it is true. So it is true. Now it is not less than 25. So uh, it is false and true. False and true is false. True, I mean, if there is or, then true false is true. But if there is and, then true and false is false. Next is, so it is also not greater, sorry, it is greater than 22, but this one is false. So this one is true and false. Okay, let me just write this there so we can do similar way. Okay. Okay. So what do we have? This one is false. Okay. Uh, this one is true. So true. Sorry, not and, not and. There is or. True or true. Now x is not less than 25. It is false. False and true is false. Till now it is false. Then this one is true. It is greater than 22. True. True and false is false. Next, it is less than 25. Now it is less than 25. No. So false or false is again false. So your answer is false. So you need to remember to do it from the last. Is it clear? If it is not clear, then I'll let you know. But are you clear about and or? Are you clear about this? So okay, just let me just write it. So for true, true. If you have and operation, if you have or operation, it is true, true. Okay. True, false, false, true, false, true, false, true, and false, 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 false. Okay, this is the condition, and when you are checking it, then do it from the last, so you will have correct value. Why can't we enter from the left side? I don't know. Let us do from the left side. I have never done. I have always done from the left, this side, and I think I kind of get the correct answer by that. Okay, so this is false, 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 or this is true. Uh, okay, so that we need to do here, I think. No? Okay, so if we move from other side, let me just copy this and paste this. Okay, so this one is basically false, this one is true, right? So false and true is false or true, sorry, false or true, it is true. Okay, then true and this is false. So true and false is mm, false, right? Then we have false and x greater than 22. Okay, so x greater than 22 is basically true, right? But false and true is again false. Okay, and then it is not equal to this, so false or false is false. You have correct answer here also, but I don't know, uh, I was quite doing from that. Maybe this one is also the correct way, but that one is, I'm sure about this, that if you will do from this side, then it will give you correct answer. From this side, I don't know. I mean, you need to check if there is a theory or not. If not, then you can from the both the side. But you need to check. Okay, I have not checked it, that from this side it will work or not. So I have not checked. I have not checked it. You need to check it if it is fine. If it is fine, then you can. Okay. Uh, okay. So basically, the later on part is not problematic. Okay, so for the sequence, we know increment decrement operator. We know sequence will go from here there. I mean, you can write in increasing way, decreasing way, and you can write this sequence along x. Then repeat. You need to just repeat and then sort. uh, the list also we have seen. So basically, and then there is formatting. Okay, then there is string data frame. So basically, these are the parts we have done so far. So one of the most important thing when we do anything is basically the loops. Okay, so that is one thing we need to revise, and then we will see some data frame, etc. Okay, so just now we have seen what is one of the use of using what is one of the use for loop, that for if else. So it is of none use if we are not able to apply the for loop. Okay, so if loops are not there, I mean not just for loop, you have while loop, repeat loop, etc. also. But if loops are not there, then just for one value nobody is going to do that much of work. Okay, so there are different loops, and we apply different loops in different condition. So for loop is applied when you already know how many times you need to repeat, because in for loop we start with I in this, I in 1 to 10, I in some data vector, I in something. Okay, and for that I will change. Okay, so if you do not know from advance, so let's say for I have some data vector of 100 columns, so I can write for I in 1 to 100, then I can apply for loop. But if you have if you want to apply something like that, that okay, perform this operation until we are not getting this particular value. Okay, so do this until we are not getting this exact thing. So for that we use the while loop. Okay, for that we cannot use the for loop if we do not have predefined condition. Then again you have nested for loop. You can loop for, let's say you have one I and then you have one j. So let's say you have columns and rows and you want to apply something in row and column, something like that. Then you can do nested for loop, that go to first column, then inside it go to first row, second row, third row, fourth row, then go to next column, and then go to first row, second row, third row, fourth row. So that is how you can do the nested. Then there is a break or next. So break, sometimes you can have that if it is happening, let's say you have not let's say you are searching for na values, then you can do that as soon as it is it equal to na, then break this loop that you have got your first value. Or there can be a lot of conditions that as soon as you have got this condition, then break the loop. Then there is a next. So next is basically, let's say you have a data and at some point there are infinity, or let's say na values. So you are saying that if wherever there are na values, then go to next. So you can either break the loop if let's say there is only na values, then you can just break. Otherwise you can say, let's say you have 30 na values, then you can say that whenever there is na value, just move to next and skip that portion in the loop. While loop, we already said that you need to give the command and with the condition. So when the condition satisfied, this while loop stops. In repeat loop, you need to give the break, because in repeat loop, what happens? It repeats. Okay, it will do the same work again and again. So if you have not given the break, it will just continuously run. Okay, so let us see some examples. So I have given just x here, and I have just printed that for I in x, print the square root of I. So remember, I have not written a square root of x. I have written a square root of I, because what is my I? I in x. So I right now will be just 31 value, because I is updating. So I is firstly 2, then 4, then 2, 15, 18, 31. The other way you can do is that for I in 1 to 6, uh, 1, 2, 3, 4, 5, 6. So what is other thing you can do? I in 1 to 6. Okay. Uh, print square root of xi. So then also you will have same answer. Why? Because xi, x1 is this, x2 is this. So there can be a lot of ways you can write the same loop. So previously I have given that I in, so previously I have saving my I as x values. So I was 1, 4, sorry, 2, 4, 2, 15, 18, 31. Right now my I is 1, 2, 3, 4, 5, 6, and I'm giving x and I as an index. Here I have given I as values. Okay, so I hope it's clear. Okay. The next is how we can perform the loop one. So if I'm writing this, then I can perform for j in x1, 3 to 5, let's say for some index, and j I in x 1, 2, 3. So x and x1, and then print I minus j. So that is one thing we can do. The next is we can do that if it is, let's say, if as soon as I is greater than 17, uh, so my x1 is this, so I is greater than 17 at this point, so it will just break the loop. So it will not give you value for the 7 either, because it will just break loop at this point, it will not move any further. But if you want to move further, then you need to write next. So when it is greater than 17, then move to next. So you can see that the sign of 7 is here. So it is giving the sign of where was x? The sign of 5, sign of 6, sign of 8, and 19 is greater than 17. So move to next. Next is 7. So sign of 7. Okay. Uh, Similar way you can do for this also. Then while. So for while, you can see that I have not given condition here. Sorry, I have not given how many times you need to go. I'm just given I less than 21. So if I'm writing I is equal to I plus 1, it will work like this. If I will change it like this, then you can see there are very less values. So it depends on me that how much values I want, and then I can give condition I is I plus one, I how I is changing, so how I is gonna increase. The repeat loop, you can see, if I remove this, sorry, if I remove this break condition, then you can see what is going to happen. It is just gonna work. Why? Because I is 1, I is equal to I plus 2. So I is 2, I is 3. So it is just gonna keep running. So you need to press ESC. If you will put ESC, it will stop. So for that repeat loop, you need to give the break. So I have given break. So when it is greater than 30, it will break. Then there were some examples. Okay. Okay. So till now, any questions? Anyone have any questions? Okay. Good. Okay, these are some questions which we can do. I have given for loop and then checking, etc. So these are some questions which we can do. Okay, so we have just seen what will happen in C bind. So if I have x from 1 to 20 and y from 11 to 20, what do you think will be the result of C bind? Okay, we have just seen that. Okay, I have not written here, I think. Uh, I've written in that part only, I think. Okay, so this one. So C bind M1 and then M2 is gonna come here. So if you have M1 then M2, so it is not matrix but is still it will work. So if I will write, I already have a lot of this. So X and X1. So if I will just write C bind of X comma X1, uh, number of rows of result is okay. So it does not have same number of rows. Uh, Row needs to be same. Okay, so let me do this. Yes. X is 1 to 20. Oh, 1 to 10. Y is 11, 20. Okay, so what C bind does, sorry, it was not the same. I think, yeah, it was X1 was X1 and X was different. Okay, so now we have same, and for C bind, what do we do in C bind? We just stack the columns. Okay, we stack the columns M1, M2. Okay, so row needs to be same. So M1 and M2 will be the stacked one. So what is this answer? So I think now it is much clear, right? It is 10 by 2 matrix. The 10 is number of row and 2 is the number of columns. So it is 10 by 2 matrix. Okay. What do you think will be this answer? Which x greater than 10? So which is basically for the index. What will be the indices at which x is greater than 10? This is very simple, I think. I think this is very simple. I don't know whether you want to answer or not. Okay, so this is not, this one is true and this one is not true. Okay, so second and fourth index is basically when it is this. Okay, now there is if else. So what do you think will be its answer? So x is given, y is if else. If it is Na, then 0. If it is not Na, then give x. So this is basically you can see as a function to replace Na values by 0. Okay, so for the first one, so 3 is not Na. So result will be, so it is yes or no. Okay. This one is yes, this one is no. Right? So 3 is not Na, so it will result x, which is 3. 5 is not Na, so it will result 5. Now Na. So third one is Na. So is dot nax, it is true, so it is yes. So it will be 0. And the last 8 is not Na, then it will be x. So 3508 will be your answer. Okay. The next one is that uh, given given the vectors a c 2 4 6 b 1 3 5, what will be the result of a? Now this one is modulo division or integer division? Which one it will give, the quotient or remainder? Will give you the remainder. We have just seen, you can remember by this, if there is division sign in between, then you can see that okay, this is basically the quotient is what, like the integer form of whatever result you get. So you can see that this is the for the quotient and this one is for remainder. So the remainder will be 2 is divisible by 1, so remainder is 0. 4 divisible by 3, so 1 time, and 1 is remainder. 6 divisible by 5, 1 time divisible, and 1 is the remainder. So 0, 1, 1 will be the correct answer. Okay, so the next is that firstly you need to do this and then you need to do this. Okay. Why you are not answering for any question? You can answer, you can write in the chat box directly. Am I the one who is not able to see? Okay, so which v divisible by 2 is equal to 0, 0. So there is no v, right? There is no v which is divisible by 2. So let me just write this here. And so there is no v, right? So it is giving numeric 0. So basically you do not have any values, no values. So you can basically take that no. Okay. Okay. Then there are loops. Okay. So there are two questions from the loops. Uh, the question is basically for this, and this one is nested if else. Okay. So what it is saying, the outer is 0 for I in 1 to 2, for j in 1 to 2, uh, outer equal to outer plus I plus j. So what happens, firstly right now outer is 0. Firstly what will happen, the I will be 1, I will be 1, and then j will be 1. Okay. Let me shift this one below. Okay. So outer will be uh, so right now outer will be, outer is 0 and then I plus j. So outer is right now 2. Now I is again 1, j will shift to 2. So outer will be 2 plus uh, let me write in separate line, otherwise it will be very confusing. It will be 2 plus 1 plus 2. Now my outer is 2 plus 2 4 and then 5. So for I equal to 1 it is done. Now we will have I as 2, j as 1. Okay, so I is 1, so 1 2 j is done now. So this one was when I equal to 1, j equal to 1. I equal to 1, j equal to 2. Now I equal to 2, j equal to 1. Outer is 5, I is 2, j is 1. So 5 to 7, 1, 8. Okay. Now at the end I is 2, j is 2. So 8 plus 2 plus 2, 10. So 12. So 12 is the correct answer. Okay, is it clear? Okay, so the next is nested if else. Hmm. So and then check. Okay, so what it is saying that firstly check if x is greater than 0, then check if x is greater than 10, then assign result. But if x is greater than this, sign this. If x is odd, result is 50. What is value of result for x is equal to 8? So my x is 8. Okay. Firstly, I have checked x is even, so it is true. Then check if x is greater than 10. No, it is less than 10. Assign it is 100. Okay, so this is the answer. If x is odd, then it will be 50. But x is not odd, x is even. Then we have checked x is not greater than 10, x is less than 10. So we have assigned it 100. So this type of questions you should understand. Okay, you need to write it in very fair way. Otherwise, you can mess up this. Okay. Okay, so we have basically seen, so install and install, that was very basic thing. The rm is used to remove, uh, what do you think? If x is a data vector, what will it give? X. So we have just seen actually. So inside one, x greater than 5, inside one will give you the logical one. And as soon as you write x and then index of this, then it will give you the value of x. So it will give you the value of x. The next is when to use is dot numeric, when to use as dot numeric. As dot numeric is basically you kind of try to extract whatsoever numeric is there. Okay. So if I'm writing, let's say x is equal to 2, 3, and y, let's say in a data vector, then the numeric one is 2, 3. So y is not the numeric, it will extract. Is dot numeric is checking that whether it is a numeric one or it is a character one or is it a list one. So kind of is dot numeric is for checking, it is not for that. So these are some questions you can ask. Integer modulo, integer division, modular division. We have just seen that. Okay. Then GCD. So when you have length of vector 2, then it will give you warning. Okay. The next we have just seen that we need to give the data in the vector form in min max. So, uh, there space. Uh, for this one actually, for this one, it is not working. Therefore, okay, I think this is very small value. 3, 3. Okay, now it is looking a bit better. So you can actually write whatsoever you think you can forward here. Then we have gone through the matrix each and everything. Cross product we have seen. Actually, we have not just written that. But cross product is transpose of x multiplied by x, not x multiplied by transpose of x. So this one is the correct answer. So then you need to remember that in R bind and in C bind. So we have just done that. Missing data, loops, constructing functions. So constructing function is basically how we can construct. So we have seen that we can just give this, we can just define this function of x, and now whatsoever way I have defined. So function x, you will give whatsoever variable you want to give. X variable, y variable, a, b, c, d. There is nothing like that. And then here you need to give, if it is x, you need to give, let's say, one value. One. You cannot give two values. Okay. You can see unused argument. So it is not there where to place. So this one is function defining. Then you can basically make a loop that okay, this is the loop, so it will find cube of minus 10 minus 9 0 up to cube of 10. Okay, the next one is uh, and sorry, it is not cube, it is cub. So cube is not cube like 10 cube, it is a function, cub function. Okay, then you can define in bivariate, so x and y. So if now you need to give or you need to use two loops, that I is changing and j is changing, so that is one thing you can do. Okay, that is regarding the function. And then sort, order, so these are very direct functions. Okay, so if you will just write sort, you can write sort x. By default, that can be decreasing, so you can write sort and decreasing equal to false or true. Okay, so if you want it in increasing order, write decreasing equal to false. If you want in decreasing order, then you can write decreasing equal to true. Then you have the order based on that. The list, we have seen the list. Also in list we will see one thing. Um, in list also we know, we can merge list, but for merging of list it is not there, is there are no condition, there are literally no condition. Mm, so you can just write that to list and then it will just merge. Okay. Okay, the next is that construct. Okay, we have done up to this. Okay, and then there is find and substitute. So these are very recent classes. So find, we can find one thing inside a string, and then we can substitute by this sub or g sub. So if you want to substitute only first time, then we use sub, and if you want to substitute all the time it happens, let's say ex or sey, this came a lot of times, then you can, and you want to substitute all, then you can use g sub. Then we have seen data frame, combined and merge. Then we have seen data statistics, which is basically the summary, mean values, etc. We have seen the frequency table, the graphics. So graphics is just we have done in Tuesday class. So I think that will be uh, much clearer. So the one thing which we can see is the data frame. So it is of week 10. Okay. So I'm just opening it. If you have any question, you can ask. Okay. Kindly explain last question of week 12 from the assignment. Is it? Yeah. Okay. Sorry, this one is the solution. This one is the okay. Okay. What is given here is that, like, basically, you need to write the function, right? Correct function. So, okay. So, which one is the correct code of function to obtain the value of following function on the basis of given data values? Okay. So, firstly, you can see that data values are given in all. Okay, now this is the function. Okay, so function is of xy function. Now n is our length of x. uh, okay, so To define this function, how do we define it? uh, the first thing you can see which is repeating is this, right? Xi divided by root yi to the power 3 by 7 summation of it. Okay, that is one thing you can see, that this one is repeating again and again. Okay, so what you can do is that, okay, let me just see the answers firstly, how they have defined all the time this. Okay, so what we can do is that we need to write this as one part, xi divided by root yi. Okay, and then there will be a for loop for I equal to 1 to n, and it will save this. Okay, so it has, let's say, saved in zi. Okay, fine. uh Now the question is, uh, will let uh, just summation of z firstly. Okay, so now what you need to see is that, uh, this one. Okay, so firstly they are very sparse way. Now, if I will do like this, zi is xy by square root of yi. Okay, and I do summation of it, what will happen? I have done summation of it, but this is not the correct form, right? Because I need to do this operation firstly. uh, L- Firstly, I need to do this, then I need to do this, and then I need to do its summation. So, this first answer is not correct. Here, if you will see that, then it is done. Okay, xi by square root of yi and to the power 3 by 7, and then they have taken summation. So, which is correct form. So inside part is done. Next is log of this z divided by exponential of cube of this plus this. So the next is, you can see, log of xy, which is correctly written here, then divided by this, and the bracket is also here, then exponential of this. Okay, and to the power 1 by 3, which is also correct. Then it is written, then absolute value of this, absolute value of gxy. Okay, so now you can see it is wrong here. It is writing gxy to the power 1 by 5 firstly, whereas I want absolute value firstly and then 1 by 5. So you can see, we have seen that first option is wrong, because you need to do the power operation firstly and then you need to do summation. The second option is also wrong. Uh, then then the third option is also wrong, because uh, they have not done the power operation here. It is not cube root and it is not to the power 1 by 5, 3 by 7 or 1 by 5, whatsoever it was given. Okay, the fourth one, what they are doing is that, they have done this. Okay, so apps gxy, they have given this as a correct answer. Okay, so I mean, the most better answer is this one, but this one is also not correct. We can see, because we have firstly absolute gxy, and then we have done its power 1 by 5, right? But they have written the absolute gxy to the power 1 by 5, gx to the power 1 by 5, and then taking the absolute value. So this is a bit wrong. Otherwise, the most accepted answer is this, but this one is also not correct. Okay, because this one is also wrong, because we have done summation firstly. This one is also not wrong, because they have not done uh, a much more work. So this is most acceptable, but this is not correct. So the correct one will be, can I copy this? Can I copy this? Okay. Uh, and I will take a screenshot of it. Okay. What it? Okay. So, okay. So this one, and then it should be, uh, okay. So it should be, this one is not correct. This one is the correct one. So there is, I think the most suitable answer is this. That's why they have written it like this. Any issue? So, in just repetition, I just want to say is that firstly, you need to see is there anything common. If there is anything common, so let's say this one xy divided by root yi to the power 3 by 7, this is the most common in all these, right? This summation, this is the most common. So, you need to do this as one, and then now it is just a value. So you can just put z exponential of z to the power 1 by 3 plus absolute value of z to the power 1 by 5. So now it will look much more simpler. Is it clear? If summation some symbol is removed, how will the code change? uh, okay, so see, first thing is that uh, you will not have one single value, right? Because if you will not have this summation, that means you are applying this at x1 y1 and x1 y1. So you will have one value for x1 y1, then you will have another value for x2 y2. If you are saying that like there is no summation and there is one loop, so that will depend what kind of function you have given. But if there are multiple values and you are not using summation or some summation basically, then you will have multiple answers. Okay, you will maybe print again and again, so this fxy will come again and again and again, uh, for x1 y1 x2 y2 x and yn, 10 values, let's say. Mm, uh, okay, so I this one is saved, so a lot of things will change. You will not need to save this z as this. um, okay, let me see if we can do with a bit of change. Okay, so let us see. I'm giving one, two, four values and three, five, six values. Uh, okay, so this is g of xy. Mm, why it is ended there? Should not end here. Should end here. or maybe you can write directly z. So g of x y, and this x y, and then f of, I will just write f. Then it will save f. Okay. So there are still some problem in this code because they have not written it all in one go. Okay, so G is function basically, and what I want is that I mean there is no need for this. I will just give this of G and F. So G is this and F is this. F is giving as a function. F is still not taking it as a value. I don't know. Okay, let me copy this again. So G of xy we know it should return fxy, but it has not returned anything. Return fxy. There is no answer. The only thing is that you need to write this. If I will make a function like this, xy, I have said it that I will give this. I don't know. I think there is some issue because it is not returning anything in this way. So if I'm using this f just okay. Now it is fine. So I think there was another fxy that was the problem maybe. So uh, when I'm having this gxy is this and f is this. Okay. Uh, if we will remove this summation of z, then what will happen? Uh, it will basically save the only last value. Okay, so if I remove this summation, okay, so it is doing this for all three, 1 2 3. So my f is for all three. So This one is for x1 y1. First value is for x1 y1, x2 y2, and x3 y3. So if you want to remove the summation, then you will have these values. Is there any question? Difference between qualitative and quantitative variables in graph. Uh, it will depend. See, firstly, uh, in the quantity wise also, there are the quality wise. So firstly, what we have, let's say we have the categorical variables. Okay, so we can write, let's say, very bad, bad, good, and then very good, and let's say excellent. So let's say we have five values. So this is qualitative, but at the end for the coding we change it to the quantitative. So it will be 1 2 3 4 5. So if in that way you think, then all are the quantitative wise, but then it is qualitative, of course, 1 to 5 if we can do. The next is that we have whether it is a continuous variable or it is a uh, discrete one. Now in stats we do not consider the continuous variable as 0 to 1 class. Okay, if you have let's say 0 to 1, what do we say is that it is not exactly that okay you need to have all the values between 0 to 1, but what do we say is that we can have any value. I can have 0. 0.8, 0. 0.7, etc. So the difference is that for the qualitative variable we use the bar plots, that okay for 1 2 3 4 5. So if you are you can use the pie chart. Basically you know that okay this much of percentage is belonging to this particular class. For that you can use bar plot. And if you have continuous variable, as I have said, that it can take, let's say I'm saying my range is 1 to 100. So in real life, let's say the temperature. Okay, so the range is, let's say for today's temperature it is 11 to 21 degrees Celsius, but it will not have, you will have exact 11, 12, 13 values, right? You can have 11.2, you can have 11.5 degrees Celsius. So that means it is a continuous variable, it can take any values, and for that we use the histogram plot. So that is, I have said a lot of times till now. I think we have done a lot of plottings too for that. So for graphics, you use a bar plot or pie chart for qualitative, and for quantitative one we use the histogram plot. Then there are density plots, etc. You can find which kind of density it is following. It is a normal distribution, something like that, or exponential or log normal. So that can be a different thing. Okay. Okay, so is there any other question you have? Okay, so thank you, and all the best for your exam.